Hello seniors, today we're going to finally see the last part of electronic assignment number 14, which is about derivative and graphing. This is part 4 of the electronic assignment, and we are going to see how to interpret all of the different things we have learned about the first derivative and about the second derivative. We're going to graphically see how they look when we sketch the functions, the same three functions we were working on during the previous videos. Okay, so what I did here is I wrote a summary of the different characteristics that we obtain from each of the functions. For example, in this case is function A, the first one, part A, and I wrote all of the interesting information that we got from the first derivative criteria. Remember, from the first derivative we determined the intervals where the function is either increasing or decreasing, and we found points corresponding to either relative minimum points or relative maximum points. Okay, that's what we found with the first derivative criteria. Then, with the second derivative criteria, we could determine the intervals where the function was either concave down or concave up. Okay, if you remember, concave down means that the function is bent downwards, right? And concave up means that the function is bent upwards. Okay. Finally, we have also found if there were any inflection points, okay, which is the point where the second derivative is equal to 0. And one thing I added here is function analysis. This is only to take a look at the graph, at the function, and see if there could be any asymptotes, either horizontal or vertical asymptotes, to be considered for the graph. In this part B, for example, there are vertical asymptotes which we should consider for the sketch. Okay, so by taking a look at all of these characteristics written here, we're going to look at the graph, at the sketch of this first graph, function A, and we're going to see how each of these characteristics apply. Okay, so I'm going to unzoom this for a while, and this is function A. So if you take a look, there you could see all. If you take a look at this function, this is how the function A looks like. You could see that from from negative infinity to negative one is this point over here, which is this point up here. For that interval, the function is actually increasing, right? Which is what we have written here. Then from negative 1 to 2, from here to here, the function is decreasing according to our interval. And from 2 to infinity, the function is again increasing. So that's exactly what we have here, okay? So this is correct. Then, if we analyze the points, we found that 2, negative 20 is a relative minimum. That's exactly a point we get in the sketch. And negative 1 and 7 is a relative maximum, which is exactly the point we have over here. Okay, there are no asymptotes, so you don't see any asymptotes in the graph. And for the second derivative criteria, we see that from negative infinity to 1/2 is right here. The function is concave down. That means that it is bending downwards. You see that the function is bending downwards up to this point over here. And after this point, it starts to bend upwards, right? It has a positive concavity here and a negative concavity in the first interval. So that's exactly what we have here. From negative infinity to 1/2, it's concave down. And from 1/2 to positive infinity, it's concave up. And the point, let me erase this for a second. The point 1/2 and negative 13 over 2. Negative 13 over 2 is the same as saying negative 6.5. It's an inflection point, and that's exactly what you can also see in this graph. This point over here corresponds to an inflection point because it's the point where the concavity of the graph changes. Okay, so I hope it's clearer now what each of these answers we got in the previous parts are actually referring to. Okay. Let's go on to the next one, function B, which is, I think, the most interesting one to analyze. If we do exactly the same analysis we did for part A, this is what we'll get for part B. Okay, let me unzoom this for a second. There, I think, yes, you can see the whole function there. So this is function B, f of x equals x squared minus 4 over x squared minus 1. If we do the function analysis before analyzing first derivative criteria and second derivative criteria, we're going to do a function analysis, which is just to be able to determine if there are any asymptotes. Remember, the rule to find an asymptote, a vertical asymptote, is to set the denominator to 0. If we set the denominator to 0, we would get two values of x, which make the denominator 0, which are +1 and -1. Those two values make the function undefined. So this corresponds to vertical asymptote. Remember the equation, x equals something. X equals something corresponds to the equation of a vertical line, okay? So we have two vertical asymptotes at 1 and -1. If you take a look at the graph, that's exactly what we see. This value over here is -1, and this value over here is +1. And both of these lines are vertical asymptotes of the function, okay? So that's it for the function analysis. If we go then to the first derivative criteria, we found the intervals where the function is decreasing or increasing, right? Remember, I just copy-pasted the answers we got in the previous sections. So if we analyze this, from -∞ to -1, the function is decreasing, and that's exactly what we see. We come from -∞ and we go to -1, which is a vertical asymptote, and for that interval, the function is actually decreasing. It's going down, right? Then from -1 to 0, from -1 to 0, that's this interval over here, the function is still decreasing, right? That's exactly what we got here. Then for the interval 0 to 1, the function is increasing. That's exactly what we see here. From 0 to 1, the function is increasing. And finally, from 1, remember this value is 1, to +∞, again, the function is increasing, okay? So the values obtained there are correct. Then we have also found that there's a relative minimum point at 0,4, and that in this point over here is exactly the relative minimum, okay? You see that although it's not the lowest point of the graph, it corresponds to a relative minimum because the function is decreasing here, and after that point it starts to increase. So that's what we call a relative minimum, okay? Although it is not the lowest point, it is still considered a relative minimum. Then, if we analyze the second derivative criteria, we got that there was no inflection point, but we got intervals where the function is either concave up or concave down. So, from -∞ to -1, we got that the function is concave down. And yes, it is concave down because the function is bending downwards, right? It's going down, and at the same time it's also bending downwards. Then, from -1 to 1, it is concave up. That is, from -1 to 1, it's all of this u over here. It's concave up. Why? Because for all of this interval, the function is bending upwards, right? It is decreasing here, then increasing here, but the whole time it is bending upwards. It has a positive concavity. And finally, for the interval 1 to infinity, it is again concave down. From 1 to infinity, you see that the function again is bending downwards, or although it is increasing here, as we got here, it is increasing, it is concave down, meaning that the function is bending downwards, okay? So, this is the analysis for function B. Now, let's go to the last function, which is, I think, the simplest. F of x equals x cubed. It's a cubic function. This is how it looks like. So if we analyze the different criteria, from the function analysis, we see that there are no asymptotes, there are no values of x in this function, which make the function an indetermination or undefined, right? So there are no asymptotes. If we analyze the first derivative criteria, we got these results from the previous videos. From from -∞ to 0, the function is increasing. That's exactly what we see. The function is increasing until this point. And then it says that after that point, from 0 to infinity, again it is increasing. So from 0 to +∞, again it is increasing. That's correct. Then for the second derivative criteria, we found that the point 0, 0 is an inflection point. And we can see that. Why? Because before that point, this function is concave down, right? It is bending downwards. And after the inflection point, the function is bending upwards, right? So it has a positive concavity. So because there's a change in concavity, we say that the point 0, 0 in this case is an inflection point. And that's exactly what we see here. From negative 0, so from negative infinity to 0, the function is concave down. And from 0 to positive infinity, the function is concave up. It is bending upwards. Okay, so I hope that with these graphs, the interpretation of each of these criteria, the first and the second derivative criteria, are clear now. Okay, so to finish,